So this is a new video, number 87. I did a lot of these area of regular pentagon problems in the prior couple problems in the previous video. But we'll go ahead and do this one here. This is the octagon. And the side length we know is 12. And the approach, find the area of one of the triangles, one of the pie slices, and we'll figure out and multiply it to get the full area of the pentagon. So let's take an analysis of this particular triangle here. We know that its side length is 12, so we have two pieces of 6 here. And again, we're going to have to use trigonometry to solve this one. To get this angle right here, if we visualize all the different slices of the octagon, there's 8 slices. A full circle is 360 degrees. There's 8 pieces and 8 slices there, so if we take 360 divided by 8, we're going to get 45 degrees. So we know that that angle is 45. I'll draw it down here as well, 45 degrees. Because this is a isosceles triangle, these two base angles will add up to 135, because 180 minus 45 is 135, and so these angles here are 135 divided by 2, which is 67.5. So that angle is 67.5, as is that angle, 67.5 degrees. Here we actually have the base of this triangle. We have 12, so we're just really need to find the height. To find the height, we're going to use some trigonometry here, so I'm going to call this h. And if we zero in on this right triangle right here, and we know this angle is 67.5, relative to this angle we know the adjacent side of 6, and we're looking for the opposite side. So if we have adjacent and opposite, I wrote those backwards, opposite, adjacent, tangents, what we go on here. If we memorize or think about SOHCAHTOA. So we'll write the tangent relationship. Tangent of 67.5 degrees is going to equal opposite, which is h, divided by adjacent, which is 6. So the height of this triangle that we've created here is going to be 6 times the tangent of 67.5 degrees. And if you put that in your calculator, you get 14. If I round to 2 decimals, 14.49. And so now we have what we need to find the area of this triangle. This area is 1/2 base times height. We know the whole base here, see it up here is 12, or 6 plus 6 is 12. And the height we just computed right here, 14.49. If you put that in your calculator, you get 86.94. Again, don't forget that's only one of these triangles. There's 8 of them because it's an octagon. We have to multiply our answer by 8 to get 695.5 inches squared. Looks like the answer key has 0.3 inches squared, so I don't know, there must have been a different rounding, whoever put this together, but this is the approach that you should use. So this question is asking to find the exact area of circumference of a circle. Whenever you see the term exact area, you're going to leave pi in your answer, because anything else is not exact, because pi is an exact number that goes on forever. So if you ever round pi, you're giving, it might be a very accurate answer, but it's not the exact answer. So we have a circle here, diameter of 14 feet. We know the diameter is across the circle, so the radius in this case will be 7. So the circumference of a circle, 2 pi r. Or you can think of it as pi times diameter, however you like to do it. So if you think about it as 2 times 2 pi r, we're going to get 14 pi. Or if you like to think of it as pi times diameter, hey, 14 pi, same answer. So that's the circumference. The area of a circle is pi r squared. So pi r in this case is 7 squared. 7 times 7 is 49. So it's 49 pi. These units will be square feet. this unit, so will this be feet. Here another circle problem. We're given a circle. We know the circumference all the way around is 26 pi units, and we're asked to find the area. Well, first of all, let's think area is pi r squared, so we really wish we had the radius. We don't have it. So the question is, can we use the other information to get it? Well, yes, because we were given the circumference, and we know that the circumference is 2 pi times r, and the circumference is provided as 26 pi, so that equals 2 pi r. If we divide both sides by 2 pi, we get, these will cancel, r is 26 pi over 2 pi. Pi's are just a number, so pi divided by pi is 1, so we can cancel it. 26 divided by 2 is 13. So we know that the radius is 13, so now we're in business. We can go back to our area question and find pi times 13 squared is 169 pi units squared. So if we're looking here for the 90 area, the shaded region, we have basically a circle with a square taken out of it. So this is going to be one of those big minus little problems again. So the area of the circle is going to be pi r squared, and we're just given the radius here, so that's pretty straightforward. Pi times 6 squared is 36 pi, so that would give us the area of this entire circle. Now we need to find the area of this square. Let's see, well, so we've got an area of a square where we're given this distance of 6. Well, let's see, we need to do a little bit of work now to get the side of a square here. So we can continue this on, so we know the whole diagonal of the square is 12. And we know that this is a 45, 45, 90 triangle. And so 45, 45, 90 triangle, you have s square root of 2. So to get from a leg to the hypotenuse, you multiply by square root of 2. To get from a hypotenuse back to a leg, you divide by square root of 2. So that's what I'm going to do here. I want this side, so I'm going to take 12 divided by square root of 2, and that's going to be the side. And then, so the area of a square is just base times height, or side squared. The side we've just found over here as 12 divided by root 2. We square that. 12 squared is 144. Root 2 squared is just 2. So that's going to be 72. So to get the area of the shaded region was 36 pi minus 72. And that's units squared. And actually, if you put this in your calculator to the nearest tenth, you get 41.1, and that's actually the answer here, unit letter A. 2, you don't really need to know how to do this. I don't think you did geometric probability. If you were interested in what the answer would be, though, again, you won't be responsible for this, but think of this as you're throwing darts at this circle, and you're trying to decide how many times does it land in the shaded area. Well, it will land in the circle area, the circle 100% of the time. So if we put that in the 36 pi as the denominator, the fraction of the times it hits the shaded region will be that area. So it's essentially a ratio of area problem. So it's 36 pi minus 72 in the numerator. And if you do that fraction, you would get 36.3%. But again, this is not on final, so don't worry about it.